This is lesson 5.4, example 3, and we're going to be going over identifying an extraneous solution. I had briefly talked about the fact that we are going to be doing this when we're checking our answers after we solve the radical equation. So they've given us a radical equation, the square root of 3x minus 2 equals x minus 4, and they'd like us to solve for x. So the first thing we're going to do, if we look at the left side of the equation where we have the radical, there is nothing outside the radical, so there's nothing to move to the other side of our equation here. So we can go ahead and get rid of the square root by squaring both sides of the equation. Now, it's important on the right side that when you're squaring this, you're squaring everything together. You're not squaring the x and the minus 4 separately. You're squaring it together in parentheses. So on the left side of our equation, the square root and the square will cancel, and we'll be left with 3x minus 2. On the right side of our parentheses, we're going to have to multiply out that binomial. And once we do that, we're going to get x squared minus 8x plus 16. We have been multiplying binomials for quite a while now. This should be a skill that you recognize and are able to do. So now we've got 3x minus 2 equals x squared minus 8x plus 16. Now we've got to get everything to one side, since we've got a quadratic with our x squared on the right. So we're going to subtract 3x from both sides, and we're going to add 2 to both sides. So now we have a quadratic that's equal to 0. And since we have a quadratic equal to 0, we do know how to factor and solve this. So in order to factor this, we are going to use x method. A times c on the top, which is 1 times 18, so 18. B on the bottom, which is negative 11. And now we're looking for two numbers that multiply to 18 and add to negative 11. And those two numbers are going to be negative 9 and negative 2. So I can rewrite my equation now as factors with 0 equals x minus 9, x minus 2. And then I'm going to take each of these factors and set them equal to 0. X minus 9 equals 0, x minus 2 equals 0. So we've got one term where x equals 9. And our other term where x equals 2. But now, just like before, we do have to check these and make sure that these work. So we're going to take these numbers and plug them back into our original equation one at a time. So for our first check, we'll check x equals 9. We'll have 3 times 9 minus 2 under the square root equals 9 minus 4. 3 times 9 is 27 minus 2. 9 minus 4 on the right side is 5. 27 minus 2 is 25. And the square root of 25 is indeed 5. So in this case, we get 5 equals 5. X equals 9 is a good answer. Now we also have to check x equals 2. So we'll have the square root of 3 times 2 minus 2 equals 2 minus 4 on the right side. 3 times 2 is 6. 2 minus 4 is going to give us a negative 2. 6 minus 2 is going to give us 4 underneath that radical. The square root of 4 is 2. 2 does not equal negative 2, which tells us that x minus 2 is extraneous. Extraneous just means extra. It is not a valid solution. So our only answer to this equation would be x equals 9. Go ahead and do try it number 3 on page 126 in your workbook.